Okay, so we are in this book, Causal Inference and Statistics. We're in Chapter 1, Question 1.33. So this question is dealing with a few basic laws of probability. And so we'll walk through those. But basically, we need to take a situation that is described in Section 1.37. The book says 1.36, but that's a typo. And we need to define a couple of conditional probabilities. So let me describe the scenario that's given in section 1.37. Okay? So basically you're in a casino and you hear some dealer somewhere yell 11. And just based on your knowledge of the games at this casino, this could be either a game of craps or a game of roulette. In the situation described in section 1.37, there's an equal number of craps games and roulette games, but that assumption is going to change when we get into parts A and B. And what's important here as well is that the probability of an 11 in craps is 1 out of 18, and the probability of an 11 in roulette is 1 out of 38. Okay, so to go about, here's the first question. So we want to find the probability of craps given that we hear 11. And we have to assume that there's twice as many roulette tables as there are craps games going on at the casino. Okay, so there's a few ways we can solve this. The most straightforward way is we'll just start with the definition of conditional probability. Okay, so this right here, probability of craps given 11, that's a conditional probability. And generically, a conditional probability is stated as the probability of A given B. Right? So we know the value of B and we want to know the probability of a particular value of A. And so that can be written as the joint probability of A and B, so A and B occurring together, divided by the probability of B. Okay? So if we want to translate that into the language of our question, it would be the following. The probability of craps given 11 is equal to the probability of craps and 11 divided by the probability of 11. So now we're going to further decompose the numerator and the denominator separately here. So the joint probability, we can decompose that generically for probability of A and B. We can decompose that into the conditional probability of B given A. Notice that's the reverse of that right there, times the probability of A. Okay, so if we want to translate that, we have that the probability of craps and 11 is equal to the probability of 11 given craps times the probability of craps. Okay, and so that will show up here in the numerator. And then the denominator, probability of 11, we can use the law of total probability as given in the book in sections 1.36 and maybe 1.37. Okay, and so that is all of the ways that we can get 11. Okay. So we can get here's a typo, by the way. Let me fix that. Give me just 1 second. Okay, so we want to find out all the ways that we can get 11, and we've already said that we can get 11 with either craps or with roulette. Okay, so first we need to find the probability of 11 given craps times the probability of craps. Okay, so that's the same thing as actually what we have in the numerator, plus the probability of 11 given that we're playing roulette times the probability that we're playing roulette. Okay, and so that all goes here in the denominator. And now we just need to substitute the values that were already given, and you can see how that's been done here. And so you can just start solving this algebraically, or I don't even think it's algebra, it's arithmetically. And we get a probability of about 51.4%. Okay, now for part B, we want to compute the conditional probability of roulette, given that we hear 10, and now we're assuming twice as many craps games as roulette games going on. Okay, so I'm not going to go through this step by step. The process is the same. We can just decompose everything, but ultimately what we want is an expression like this, right? The conditional probability of roulette, given that we hear 10, is the probability of 10 given roulette times the probability of roulette, so on and so forth. Okay, and the relevant values here I've given here because you might not be super familiar with roulette and craps. But anyway, we get the individual values here and we just go forward and solve, and so we should get an answer of about 13.6%. Okay, that's it.